All right, the application that you want to open up for this activity is the Waves on a String application. Normally what we'd be doing is we would be giving you a slinky that you can stretch about 60 feet with a partner, and you guys can shake it and generate wave pulses. But since that's not an option, this is an okay alternative to kind of hammer home what kind of concepts that we want to do. So you may notice here I just click the pulse. What that's going to do is that's going to allow us to send single wave pulses through the medium, and what you're going to see is that the wave pulse actually reflects back and forth. You can change the amplitude, meaning that the size of the pulse will be larger. So in that case, that's what we see here. You may notice that the pulse is dying off. You can reduce the amount it dies off by using this damping function here. So if I have very low damping, you're going to see it takes a lot longer to die off. You have an option of having no damping at all, which will make it essentially frictionless, and then you'll get pulses going on forever and ever and ever. So I think in the lab I typically recommend you do about 1 tick for most activities, and you can end up seeing what happens. What you want to do is you want to look at how it travels through, how it's reflected. There's a ruler here to measure the distance that it travels. There's a timer here. There's also a slow motion function. So if you use the slow motion function, you can probably time it a lot more effectively than you could using the normal time. Going back to normal time, you see the wave traveling back and forth here. This is called a fixed end right here, because if you look at the dot right here, it doesn't move. It's fixed in place, and what that does is that actually affects how the wave is going to be reflected, and we'll end up talking about that in the video further. I want you to kind of investigate it on your own. Another thing here is that I want you to focus on maybe just one of these dots here. When we send the pulse, look at how the dots move. You're going to notice that they move vertically. They move up and down. So the wave itself travels through the medium, whereas the medium itself moves up and down. So that's going to be important as you make your observations here. The other thing we're going to do is we're going to make a loose end, which means that the end can actually move. So when you send the pulse through, you're going to see a different type of reflection. So we'll take a look at that. You may notice here, this is still fixed over here. So you have that. At some point in time, we're going to have to use the oscillate function. Now what that does is that generates continuous pulses. Instead of one single shake up and down, it's just going to continuously do it, and you're going to get something that looks like that. Now actually, if you have a slinky at home, what you could do is like tether it to an object and shake it to your heart's content, and you'll end up seeing this in the medium. I'll probably try to do something like that in some sort of video for you, so that you can see what it looks like in real life. But this is what continuous motion would look like. And I put no end here so that it doesn't reflect, but if it reflects, you're going to see that you get a big kind of mess here going on. At some point, we're going to ask you to interact 2 separate waves. The way you want to do that is going back to the pulse function, and I'm going to put the damping at 0. And what you can do is you can send a single pulse. Now this pulse travels back and forth through the mediums right now, and it's not going to die off because I have the damping set to 0. And then what I could do is I could send a second pulse through this medium at the same time, and we can see how they interact. And what I've done here is you may notice that they're always on opposite sides of the medium. If you put it in slow motion, you can really see how they interact. And maybe if I can pause it at one special point. Very close. You want to really pay attention to how they interact there. Let's get rid of these 2 pulses. And I'm going to actually lower the amplitude for the next one. I'm going to venture it might be easier to do this one with the loose end, but if I want them on the same side, here I'm going to hit a pulse. That was pretty lame. Let's go up maybe to 1, and I want no damping. There's my pulse. And I'm going to wait till it comes back up on the top side. And there we go. If you noticed, the 2 pulses do interact occasionally on the same side, and let's look at it in slow motion. those were opposite sides, but you're going to see them come up on the same side. Now they're both at the bottom. They're interacting. They're on opposite sides again. They're interacting here, and then they're probably going to come back up on the top side, and you can see them interact here. So you want to see how waves interact with each other there. The last thing I think I ask you to do is play around with the tension and the timer. So basically, the string here, tension is a measure of how tight the string is, and right now we have it set to high tension. So basically, if you send a single pulse through, this is what, nope, we want no damping. If you send a single pulse through, there's your high tension. Maybe I do no end here actually. But if you send it through with low tension, you're going to get a different result. And if we send it through with medium tension, you're going to get a different result. All right, so you got to go through those, make some observations, and hopefully whatever I can do or whatever videos I can link to show you demonstrations of what we're looking to learn here, you'll get a good feel for what a wave does as it travels through a medium and how they behave and how they interact with each other.